Hello, and welcome to the ASCO Journal of Oncology Practice podcast. This is Dr. Nate Pinnell, medical oncologist at the Cleveland Clinic and a consultant editor for the journal. Pancreatic adenocarcinoma is the fourth deadliest cancer in the United States, partly because cases are detected at an advanced stage when cure isn't possible. We also know that patients with cancer often use search engines on the internet to research their disease. There is currently no good screening test to detect pancreatic cancer at a curable stage, but my guest today is going to talk to us about a truly novel and innovative idea to use patients' online habits to perhaps improve the early detection for this deadly disease. Joining me today is Dr. Eric Horvitz, a technical fellow at Microsoft Research and director of the Microsoft Research Lab at the Redmond Lab, to talk about his paper, Screening for Pancreatic Adenocarcinoma Using Signals from Web Search Logs, Feasibility Study and Results, scheduled to be published in the next few weeks in the GOP. Dr. Horvitz, thanks for joining me.
Oh, it's great to be here. Thanks for your interest.
We know that search queries are often used by marketers to direct ads to us based on what we searched, but it hadn't really occurred to me to use this for something like trying to screen someone for a health purpose. Is this a really novel idea? Is this something that's being done out there already? How did you end up coming up with the idea?
Our team at Microsoft Research has been working with anonymized search logs for a number of years. Particularly, I've been working very closely with Dr. Ryan White, my colleague, at looking at everything from patterns of search as people try to do self-diagnosis to understand, for example, how the web might make people more anxious or provide poor information versus good information to them, given the way web search engines work. We've also looked at drug interactions and identified rare adverse effects of medications by watching a consumer search on a drug and then search on symptoms that show that they may have experienced an adverse effect. And these publications are on our website. You can read about them. The most recent article in the Journal of Biomedical Informatics actually looked at divining future FDA box label changes. Before the FDA took an action, we could actually predict that that would happen based on search logs. So this foray into screening for pancreatic adenocarcinoma comes in the context of rich sets of studies leveraging this interesting non-traditional source of data from large-scale populations for enhancing clinical care. In some recent work, we actually studied the episodic nature of what seems to happen when people are diagnosed with breast cancer over time, looking at the episodic shift of their attention over the life history of an illness to understand whether or not and how well the search engine could perform in providing information as people ask questions, for example, about diagnosis and treatment over time.
What I thought was fascinating is you're trying to take it a step beyond just looking at the symptoms or the pattern of diagnosis. You're trying to identify people really before they have a diagnosis. Isn't that true? So can you kind of take me through the specifics of the concept in your project?
Yes, we've been very excited about the prospect that search engines might one day provide a low-cost means of identifying people at risk for illness and providing new kinds of advanced warning. To start with, we thought, let's explore the feasibility of web search engines and the data they collect, providing us with the ability to build automatic classifiers, pattern recognizers that could find the subtle fingerprints of the onset of an illness like pancreatic cancer, which typically, as we know, comes to the fore as nonspecific complaints and symptoms.
And so how did you basically identify your index cases, your sort of positive in patients with pancreas cancer, so you could identify their symptoms after the fact?
In working with search engines and this kind of non-traditional data, we still have to design a formal, in some ways, a clinical trial. We have to have positives and negatives and then do a holdout set and see how well we can predict it. For our positives, we identify what we call experiential diagnostic queries. Queries that say, in the first person, for example, I've just been diagnosed with pancreatic cancer. Why did I get pancreatic cancer? How can I fight this pancreatic cancer? People talk in the first person quite frequently. We also can take those queries and then go downstream in the logs and see were these people indeed grappling with this illness in terms of their pursuit of diagnostic information, comparative analyses of surgery versus non-surgical approaches, actually asking questions about the chemotherapeutic agents they will be taking over time. And so we identify a set of very compelling positives, and experts look at these cases and we understand these are actual cases with a very, very high probability. Once we have these positives, we actually go back in time and we ask the question, was there some fingerprint, some evidential pattern that could have led us to identify these people earlier than when they first indicate they've been diagnosed? And how far back could we go? And how does the false positive and true positive rate shift as we go further and further back in time? The negatives in this case are the larger corpus of people who search on one of many of the synonyms and that relate to a set of symptoms we've diagnosed as being the kinds of things people ask about on the way up to a diagnosis of pancreatic cancer. We filter a large corpus of queries that have come to the search engine over a period of time, use that to build a large set of positives and negatives. The positives are the experiential searchers, the people who actually have input a first-person query that's confirmed to be a compelling example of a diagnostic, of a true positive diagnostic case. And then we go back and we use machine learning to build classifiers that can predict over time whether each of these users will one day say that I've just been diagnosed with pancreatic cancer. Now, it's like finding a needle in a haystack because we have millions of negatives and we're just looking for a few thousand positives. So the question is, could we build classifiers that would look at this interesting fingerprint? When I say fingerprint, I mean even the timing and the ordering of nonspecific features and their persistence and their onset and numbers of symptoms that come to the fore. And remarkably, we found that maintaining low false positive rates, which you have to do when you have a large body of searchers, most of whom, of course, will be negative, even when they ask about one or more of these nonspecific findings and query them for their curiosity over 18 months. So we have to basically think about, as we do a study, clamping a false positive rate, 1 in 10,000, 1 in 100,000, 1 in 100. And at each false positive rate, ask how many of the experiential diagnostic queriers could we identify in advance, and how far in advance could we identify them? So these are based on logs to Bing, US-based logs from a period of time of October 2013 to May 2015. And what we find is that going from a 1 in 10,000 tolerated false positive rate to a 1 in 100,000 tolerated false positive rate, we can pick out, respectively, between 5 and 15%, identify them early, of these people who eventually go on to most clearly look like they've been diagnosed with pancreatic cancer. And so it seems like we have the power here, and we haven't thought through yet as to how we'd actually translate these ideas into reality. But the first step was it possible? Could we do this? And what symptoms come to the fore as being discriminating in this task? Given these positive results, I think very exciting results, that with ambient background processes we can capture and provide someday through some mechanism early warning, for example, to people who might opt into a service someday. It's very heartening and shows the power of these modern web services with the right kind of analytics and the right kind of setup to manage some tolerable false positive rate, the prospect of providing early warning to patients. And I guess one question is, again, what are false positives like? Would we ever tell somebody, would we ever imagine a system someday, even an opt-in system that's looking out for your health and wellness? I think you might have pancreatic cancer. We wouldn't do such a thing. We'd be more along the lines someday of fielding these mechanisms to, for example, suggest you might want to visit your doctor and let him know that we've identified these sets of symptoms that you've been interested in. So you can imagine ways of lowering the cost of an alert of a false positive and still getting people to take seriously when these patterns of signs and symptoms showed up, getting it checked out.
that's the natural next question is, what is your next step? Are you going to try to push the pancreatic cancer thing to more of a larger trial, or perhaps start broadening this out to other health conditions? Because it certainly seems as though this would be applicable to almost any health condition that people search on the web about.
Right. So we're already looking at other conditions with the same analytical pipeline. Hopefully, we'll be talking again about what I would consider the next breakthroughs in feasibility studies. I think that we're also learning something, right, as we go. We can learn new knowledge about location information and other kinds of habits and risk factors that you wouldn't be able to see through an electronic health record, given how limited a keyhole view that is. Now, let me also mention that there's another direction that I find very interesting, and that is to join the worlds of formal clinical trials with these tools, with these non-traditional evidential sources. We've created methods that we're looking forward to trying out that allow us to link these methodologies of looking at web searches with IRB-approved studies with colleagues, with actual patients who click on a link when they volunteer to be in a study, again, through a formal trial process, and share with us their browser code. So we actually can then link medical records, electronic health records, and actual clinical care or trials with, for example, 18 months of search history. And that's the next step in the science here, is to work with formal ground truth, patients that are being followed or in part of formal trials, and linking it to this non-traditional evidential source.
That sounds amazing. Although one of the things that occurred to me when you mentioned that is you're going to have to really sell this from a privacy standpoint, I think. And, I know that from the pilot project, it's all anonymized and you're working out your model and identifying a good way of identifying these patients. But once you try to tie it back to actually warning that individual that there's a problem, or if you're actually going to winnow it down to a smaller population, like a trial population where they're, electively participating and now may be worried that someone's going to be rifling through their searches for the last 18 months. You're going to have to be careful, I think, about making sure that patients are comfortable with this.
I think that's true, but we can imagine, again, when we get to that point, means of filtering logs to just look at certain kinds of things. For example, only looking at certain patterns or certain kinds of synonyms used for symptomatology. I think that we can get around that, especially with altruistic volunteers someday. So I want to get to that challenge problem when we're ready to do that kind of work, but I'm hopeful and optimistic we can go quite far with that. I should mention, though, back to my comments about privacy, that not only do we work with methods that assure privacy, we have an ethics advisory board of our own at Microsoft Research. And these kinds of studies go through an ethics advisory panel and process. So it's akin to an IRB style process at industry.
No, I think that that's a necessary step, and I'm glad to hear that you're already thinking about those steps. Thank you so much, Dr. Horvitz, for joining me today.
It's been great to share this exciting new research.
And I also want to thank the listeners who joined us for this podcast. The full text of the paper will be available at jop.ascopubs.org under early release articles in the next few weeks. Don't forget, you can read the JOP and access these podcasts on your smartphone or tablet with the ASCO Journals mobile app, available in the iTunes Store and Google Play. This is Dr. Nate Pinnell for the Journal of Oncology Practice signing off. Thanks for listening.